Well, this is going to be part 6 for this 2007 Dodge Ram 2500 with the 6.7. This is the one that we had a bad ECM. So if you remember from, you'd have to watch all the other parts, but part 5 it had two EGR codes and two O2 sensor codes. Well, those are gone because the guy that owns it put a tuner in it, because obviously the O2 sensors are not there and the EGR is not there. So that fixed all that, but it's still not having the best amount of power. And the reason is, just like we had these codes in part 5, we got a P0251 injection pump fuel valve feedback and a P1012 fuel pump delivery pressure too high. So it puts it in a limp reduced power state mode. Come on, focus. There we go. So, and we had those before, and I didn't know if it was part of the tune or what, but it's obviously not. There's an actual issue with it. So, if I go to live data here, that pull up. All right, so we pull it up, go to pressure. Oh, by the way, we can still pull live data. We can pull up live data, codes and everything, even with this tune on. So obviously that other computer was, well, definitely shot. Something wrong inside of it. Processor or something. So I'm gonna look at pressure. Well, I want field pressure. Hang on. Should be under field. Field pressure. Set point. Field pressure sensor. Voltage. Okay, so what we're looking at here is it wants this, and that's what it's at. So I'm going to go ahead and crank it and start it. Prindle's still on. So it wants 5131 psi. Why won't this thing focus? And it's at 12,100 and some. I'm gonna shut it off. Start it again. It's at 5,000, or it wants 5,000, it's at 12,000. I did this yesterday. It wanted 5,000. This is getting, saying like 22, 25, 26,000. I tapped the gas and this would get significantly better, but this is completely wrong. It's like double the amount of pressure. Rev it up. You can see it changing, but it's not matching up perfectly. I'm gonna go ahead and erase these codes. Key on engine off. If I go to read codes, no fault codes detected. Let's go to live data again. Now there's a sensor in here. It's called a, or not, there's a fuel pressure sensor, and there's also a FCA fuel control actuator we need to take a look at. It's a 2-wire motor that moves back and forth. We'll have to pull up service data, take a look at it. I have my oscilloscope hooked up because it is a pulse width modulated motor. So we'll take a look at that. Fuel pressure. Okay, let's do it again. Same thing, it's over twice as high that it wants. If I go to read codes, it's probably just gonna have the one code. The 1012 fuel pump delivery pressure too high active. Eventually it'll pull up the P0251. Already, I'm pulling up service data. But while that's pulling up, what you got here is you have a, God, this camera will not focus. Right there, sensor field rail pressure. Going from the ECM. Right, so you got 3 wires, sensor ground, a 5-volt supply, and the return. That's what we're reading. And then what's actually changing the fuel pressure is this FCA actuator fuel controller. Fuel control actuator. Motor, it goes up to the engine computer. One wire is a return. Fuel control actuator return. The other one's the driver. It reverses the polarity, moves it back and forth to control the fuel pressure. While that service data is continuing to pull up, if you look right there is the fuel control actuator. There's the pin off. It's 2 pins. I just got my breakout leads hooked up, so it's in series. The leads to the harness, so it's basically connected, and I can scope into it if I need to, so I can look at my waveform. Alrighty, well, that's pulling up. I did look for service bolt-ins for that code. I don't see none for the 6.7. There is one for the 5.9, but nothing for the 6.7 that I found. So, also, the guy that had this truck, he had never had this issue before he had this ECM replaced. I'm not saying it was or wasn't there, but it sounds like it wasn't there before. So, I mean, it's either a wiring thing, the fuel control actuator, or the actual ECM. And again, we bought this ECM in a place in Florida. It was $700 compared to a new one, which is like $3,600 from Mopar Dodge. There's other companies out there for like $1,500, $1,600, $1,700. I guess some $1,200, $1,300, but so I don't know. I don't have a warm fuzzy about this ECM, but we'll find out. Only because this company's been did some rework on some reviews on it. I just don't know if they're the best company out there. But we'll see. I'm not going to name the company right now because I could be wrong. But here's a diagram we looked at. So theory of operation. The fuel control actuator is an electronically controlled solenoid valve. The ECM provides a pulse width modulated driver circuit and a ground circuit to the FCA. The ECM varies the current to this valve to provide current flow to the high pressure pump based on operating conditions. The FCA is normally open valve, so it's normally open. Why won't this focus? It's normally open. High circuit resistance may cause fuel pressure to be higher than commanded at light loads. All this is a primary electrical diagnostic check. Fuel supply issues and high pressure leaks can cause the ECM to force the fuel control actuator into a region where this fault code becomes active. The ECM illuminates the mill lamp and the ETC lamp immediately. Well, there you go. The ECM illuminates the mill lamp, which is our engine lights on, right there. The other light that's not on right now, but when it's running, it's on, is the electronic throttle control. So it actuates the electronic throttle control lamp immediately. Remember him saying he did have this light on. I'll show you here. It's not on now because I cleared the codes, but eventually that ETC light comes on. He said once in a while it does come on, he remembers, so hopefully there's nothing wrong with this computer. Try it again. Yeah, you can see a flash there in the center. It's not always on, but right there. That flash right down there. It's not on now, but eventually it comes on. When that 251 code comes on, then it'll come on. Which will make sense because when I clear it, right there, that's the light that would normally come on. When I clear the codes, that light doesn't come on for a while until it throws the 251. You're gonna have to drive it for it to do it. But now, what we're looking at. So the ETC lamp immediately after the diagnostic runs and fails. During this time, the customer may experience low power, which he does. The ECM turns the mill off after the diagnostic run and passes 4 consecutive drive cycles. All right, so that makes sense why those lights are on. When monitored, the ignition is on. So when does this code set? When the ECM detects a discrepancy between the pulse width modulation signal supplied to the electronic fuel control actuator and the pulse width modulation returned from the control. So what we want to look for is, I would think, a DC square wave. We can check voltage, we can check amperage, so forth. Possible causes, punt list. Yeah, it could be short to voltage, short to ground, open. Stuff we always know, right? ECM, I hope it's not that. So it tells you can kind of go walk through these tests. But what I want to do first is I want to check with our oscilloscope the square wave. All right, there's only 2 wires there, so I'm just picking one. Which one am I on? Let me see. I'm on the black tracer here. Well, let's see what color these wires are. All right. Sorry, I had to stop. Like 3 people have stopped over here since I've started this. So anyways, field control actuator motor. I'm on the blue wire, purple wire. Yeah, right there. Dark blue. So that's the driver. And the brown is, yeah, it's dark blue and a brown. So I'm on this one right now. So the driver, I would think it would have a square wave. And then this would be a ground and, you know, for pulse width modulation on one or both of these. So I'm hooked up right now. I got nothing. Just go to a 5-volt scale. And let's start it up. And I got some... Let's go to a smaller scale. Let's go to a 1 volt scale. 2 milliseconds. Put a trigger on. That doesn't look right at all to me. I mean, I would think it'd be a nice clean square wave. And if I zoom back out, you know, like 5 volts. Let's go to, I don't know, 10 volts. 1 second scale. Doesn't look right at all. Now let's go on the ground side. Now I'm on the ground side, or the return side to start it. Same thing. Let's go to 1 volt scale, 2 milliseconds. Trigger on. Like I said, I think it'd be a square wave. This doesn't look right at all to me. So let's go back to 10 volts, 1 second scale. So now, is that because the sensor is bad? We'll take a look. All right, sorry, another person stopped by. Anyways, so I don't have, doesn't look right? Now, is that because the sensor is bad? So now what we're gonna do, let's look at service data again. You know, is it an active code? Did the DC turn? Yes, so we'll go to the next step. Okay. Field control actuator driver circuit shorted the voltage. Now, if it was, it would be, you know, 12 volts. Turn ignition off, disconnect the connector. Measure the voltage on, okay, anyways, note the K365 driver circuit. See if that matches up. Yep. K365, there's 366, 365 driver circuit. Will read approximately 6 volts at initial key on and then drop to approximately 3 volts. So that's coming from the ECM. We're going to check that real quick. So let's take a look at that right now. All right, so I am on the blue wire. I'm probed. I got this connected, so I'm probed right here, and I'm checking from the computer, the actuator driver. And it says, which is the K365 circuit, which is the K365 circuit. It says the field control actuator driver circuit will read approximately 6 volts at initial key on and then drop to approximately 3 volts. Is the voltage reading your battery voltage? Yes or no? If it's no, you go to the next one. Let's do it. 20 volt scale. 1 second. Put the key in. Turn the film. Key on. Engine off. Well, I got no fucking voltage. Sorry, no voltage. Oh, part of my swearing there. But, yeah. I have no voltage at all. That's not good. That tells me a wiring issue or a computer issue. I just started it. Same thing, no voltage. Alright, so it says, is the voltage near battery voltage? Yes or no? Well, if it was, it'd be a short. So it's no. But I don't even have 6 or 3 volts on initial, so that's weird. So no, go to here. Field control actuator return short, control circuit short the voltage. Oh God. measure the voltage on the K366 circuit, which is the return one, which is the brown one, K366 circuit. God. K366 return at the FCA harness connector. The K366 return circuit should not have any voltage present. Let's check that one. Well, I don't even have the key in it. I got the key out, it's sitting right there, and I got 12 volts. Look at that. I'm not supposed to have any voltage here. Let me turn the key on. Key on, engine off. Let's just start it. Jumps down because of the starter, and then it goes up. There's your voltage from alternator. Turn it off. Key on, engine off. Yeah, I got 12 volts. That's not good. So if and it seems like it's got some pulse width modulation, like little tracers in there. So if you go in here, it says it should not have any voltage on it. So what I'm looking at is I'm hooked this. I should not have any voltage on this return, and I got 12 volts there. Well, that's either a short to voltage in the wire harness or a short to voltage in the ECM. So is there voltage present? Yes. Repair the short to voltage in the circuit. Perform the verification test, and then boom. Okay, well that's pretty much the end of that. Because if it wasn't, then you can go to the actuator driver circuit, open high resistance, check all this, so forth. All right, so that tells me that I would think this actuator is good. It's either a short to voltage on the circuit, or there is an actual, so a short to voltage on the circuit, or the computer is shorted inside and giving 12 volts out. And that's why this truck is going into that mode. I hope it's not the computer, but what we need to do now is basically check it right at the TCM or the ECM. I mean, even if I back probe it with everything hooked up, I can still read voltage here. So I probably want to pull it out and check it on the bench and look at it there and power it up. And if I have 12 volts on the bench off that circuit, then it's inside the computer. But what I could do before that is I can unplug the connector at the computer, that connector 1, and unplug the connector up here, which I already have unplugged, and then check it up here and make sure I don't have any voltage, unless it's, you know, coming from the computer itself or another wire in the computer shorting it out. So we're going to do some more checks on that. So it's either wiring or the computer issue. But it does tell you in here, the PSI has to be within 500 plus or minus of the set point. So if it's at 4,000, it needs to be plus or minus, you know, 30, you got to be 3,500 to 4,500. If it's 5,000, 4,500 to 5,500. All right, so that's the lights. I'm talking engine light and the ETC light. It's all because of this code, and that's why it's put in this low power mode. So what we'll do now is we'll get a plan together. We'll check out, I don't know if it's going to be tonight or not. I got to do some other stuff on some other cars. Get a pizza, get a couple beers, you know. But we're going to have to do some wire integrity check, short the voltages. If that all checks good out, then it's in the PCM where there's a MOSFET transistor in there that's shorted or blowing. Hope that's not the case, but we want to find out sooner than later so those guys in Florida could give us another ECM if that is in fact the case. So that'll be it for now. Oh, and one more thing. It makes sense why it's got that high fuel pressure, because if that voltage is that high and the other side's acting as the ground, it's just keeping that valve open, right? Well, it says it's a normally open valve, so unless they're trying to close it, but obviously something's not right with that circuit at all, so we have to do some checks, like I said. I just wanted to look up under here if you can see or not. But I'm trying to get my camera in there. You can see the connector hanging right up above that harness there in the center of the screen. That's the connector for the sensor, and it goes right down to this harness here. So it's only like I don't know, a foot of wire, if that, and it's wrapped really, really well. So I highly, highly doubt it's to short the voltage. We can always use an amp clamp, a low amp clamp, and check amperage. But if it ain't, you know, pulse width modulation, if it ain't changing voltage and it's stuck on 12 like that return circuit is, so we need to, I bet you, I would imagine that it's a bad ECM, but we'll troubleshoot it and go from there. Well, I unplugged that ECM connector 1. It's unplugged. And if you look, checking the same circuit, I have no voltage now. So now I'm going to plug it back in and see if my 12 volts comes back. Alrighty, so I plugged it back in and we got voltage again. My son Evan was watching it change while I plugged it in. So I guess that tells us it's not, I mean, it still could be a short of voltage from another wire perhaps, but what we really need to do is pull the PCM out and bench check it and power it up with power and ground, so we shouldn't have 12 volts in our circuit. But it looks like it's something is internally shorted in the CCM, but we'll have to do the bench check and go from there.